This is the One Thing Podcast, and I'm your host, Dr. Adam Rindy. The One Thing Podcast brings together leaders in functional and naturopathic medicine to discuss actionable information that may unlock puzzles in the areas of gut health, brain health, metabolism, and longevity. Please note, these episodes do not replace the opinion of your doctor. They are not intended to diagnose or treat any condition. Please discuss this information with your provider and discuss your own unique personal health history before adapting this information. Please subscribe to our episodes so that you can stay on top of the most current information in these areas of medicine. Hey everybody, welcome to this week's episode of the One Thing Podcast. On this episode, I welcome on Dr. Marco Altini. Marco holds a PhD cum laude in applied machine learning and also a MSc in computer science engineering and an MSc, the Master's in Science, cum laude in human movement sciences and high performance coaching. So I brought Marco on today to unpack a topic that I'm very interested in, which is heart rate variability. He has published more than 50 papers and patents on the intersection between physiology, health, technology, and human performance. And one of these areas that he dives deeply into is heart rate variability. He's a co-founder of HRV for Training, which is an app you can download to your phone to track heart rate variability. He's an advisor at Aura, a guest lecturer at VU Amsterdam, and editor of Wearables Department of IEEE Pervasive Computing. And he's an avid runner, athlete himself. In this episode, we really went into what is heart rate variability and how it relates to the autonomic nervous system. We talk about the different tools out there that you can use to measure heart rate variability, how heart rate variability is changed by stressors, physiologic stressors, lifestyle stressors, environmental stressors, and other illness stressors. And so we understand this topic from a standpoint of how to apply heart rate variability to improve your own health and potentially the management of chronic illness. I think you'll get a good handle on the importance of tracking HRV over time and how to interpret the data better, and to add this to your list of tools to generate self-awareness and understanding what your body's going through on any given day. I hope you enjoy this episode as much as I did. HRV has been a game changer for myself and for many of my patients, and I hope you'll see the benefit of this particular variable and metric to improve our health. Without further ado, I welcome you to the next episode of the One Thing Podcast. Dr. Altini, welcome to the One Thing Podcast. I thank you so much for making the time to speak with us today.
Thank you, Adam. It's a pleasure to be here.
Yes, I'm very excited to speak with you about this topic. It's something I have a great personal and clinical interest in. And until I came across your work, I felt lost in this topic. And so I thank you for all that you've done to help clarify and educate us on heart rate variability.
Thank you so much. Hopefully we can do some of that also today.
Exactly. Yes. Hope so. So I'd love to start off hearing about when your career intersected with heart rate variability as a metric and just sort of how you came about to be so interested in this variable.
Yeah. Well, I would say it wasn't anything that I had planned many years ago. My background is more technical, maybe. I studied engineering and computer science, and I wasn't maybe particularly interested in any of the topics that we were studying at that time. This was maybe 15, 20 years ago, in the context of building websites or computer networks or computer graphics, or sort of things you would study with a background in engineering and computer science in the earlier days before maybe mobile phones and things like that. And then towards the end of my studies, I took one course on what was called embedded systems, which is what now we would consider basically wearables or sensors that are placed also in the environment. And measuring things from the body really triggered an interest. So I saw that finally we could use these skills for something that I thought was a lot more interesting, to try to see how heart activity would change, how brain activity would change, how we would respond to exercise and other stressors and those sort of things. And that's maybe where it started. So from a technology point of view, always trying to build tools that would allow us to measure these body's responses in a way that was maybe easier for people to do it, more practical, something you could do every day. And maybe later we can talk a bit about the tools. But in general, this process of trying to measure things from the body with technology, and then later on focusing more on how we interpreted this data and learning more about that part too, is a bit how it started.
Mm-hmm. Okay. And so with heart rate variability, how would you define it, for basically, and then also, just more for like the clinician, how do we define heart rate variability?
Heart rate variability refers to the fact that the heart does not beat at a constant frequency. So, but if we were to measure the time that passes between heartbeats over a certain time frame, say a minute or 2 or 5 minutes, we look at all the individual heartbeats, and there is always some variation between these consecutive heartbeats. So even if our heart rate is 60 beats per minute, it will not be exactly every second, but there will always be some variation in there. That variation is what we quantify and what we call heart rate variability.
Okay. And so this is happening behind the scenes. We really don't have any conscious control over it, from my understanding. Is that correct?
I would say partially. Let's say that a lot of it happens because of the autonomic nervous system activity. So this is why we are interested in this heart rate variability, right? We defined it, but why do we care about it, right? There is this variation, but what does it mean? So that's when the autonomic nervous system comes in. Basically, as we face stressors and the body responds to stressors, the activity of the autonomic nervous system changes, so that, for example, if there is a stressor, the parasympathetic branch of the autonomic nervous system is suppressed. This is the branch that normally is in charge of rest and recovery functions. So this is somewhat impaired, while the sympathetic nervous system, the other branch, the one that is in charge of basically taking action when we need to utilize the resources and respond to the stressor, is more active. So this change in the autonomic nervous system activity is something that is reflected in heart rhythm. So the autonomic nervous system innervates the heart in a way that when we have reduced parasympathetic activity, the heart rhythm will become more constant. So heart rate variability becomes a way to measure indirectly how the autonomic nervous system is responding to stress. And that's why it becomes interesting, because we cannot really go and just measure parasympathetic activity on the autonomic nervous system and the stress response, but we can measure something that is changing based on the autonomic nervous system. So if we measure HRV and we see a suppression, then we know that there is a higher stress on the body. And that's a way that we can use to track this response to stressors. And that's why basically these tools can become useful.
Yeah. And that term stressors, I think we could unpack that a little bit, because I think the lay understanding of stress is sort of this state of being where the demands of life have exceeded capacity. And when we're talking about stressors, it goes beyond that. Can you unpack that a little bit and just sort of talk about all the different types of stressors, or some of them at least, that would impact HRV?
Yeah, for sure. I think in simple terms, we can think about anything that creates a disruption, and that could be exercise, it could be diet, It could be how we sleep, could be traveling, could be the menstrual cycle, it could be sickness. So all sorts of things that are happening to ourselves or in the environment we are in. Also, it could be the heat or altitude. All sorts of things that are impacting us in a way or the other will create a disruption, and the body will respond to basically go back to a normal state. This is the whole concept of just homeostatic control, right? There are disruptions and the body adjusts to these stressors and then tries to normalize again. But in some cases, maybe we cannot just normalize as easily, right? It could be that we might need a couple of days, or in some cases, we might even need longer if we have repeated stressors that become chronic. This could be even issues with work or in the family, any sort of psychological stressor that is always present. So all of these stressors will have an impact on our body and on our physiology. And that's what we can try to capture also both acutely in the short term and chronically in the longer term using measurements of heart rate variability, for example.
Okay. Yeah, it just dawns on me that when we use this term, listen to your body, it's like a term that's often taught to people as they're going through day-to-day health challenges, and also to athletes, listen to your body. It seems like we're in effect largely saying listen to your autonomic nervous system, because it's telling us a lot.
Definitely that is one of the aspects that are the most interesting, especially because they are easy to measure right now, right? So there are a lot of other changes, like in hormones, for example, where it is just not as practical, right? So it is a lot more difficult to know in real time what is happening, or for people to experiment or measure these things outside of the lab. So as a result, I think we always focus, at least with the work we do right now, on one of the two main aspects of the stress response, which is the autonomic nervous system response, and then there is, of course, an hormonal response. That is, again, a bit more outside of what we can measure non-invasively these days. But I think there is a lot indeed that we can see in the autonomic nervous system response and in how we can use that data effectively.
Yes, and one of the turning points in my understanding of HRV came when reading your work about the importance of understanding your baseline HRV versus just sort of like moment-to-moment measurements. Can you explain why trends in HRV are more important than what your actual score is? Say if someone's looking at their watch and they have an 8 versus a 7 on any given day. Can we go into that?
Yeah. So I think two aspects here. The first one is the importance of measuring HRV in a certain routine. This is important because the autonomic nervous system is always readjusting, as we were saying, and maybe you just ate or you just went for a walk. All sorts of things will create changes in your physiology, and most of the things, we don't really care about them because they are just transitions and they're quick transitory changes, and then you're back to normal. So we do not want to capture physiology during these transitory changes. We want to capture physiology when it is representative of your overall state. And that means basically that you need to measure HRV either first thing in the morning or throughout the night. So these are two conditions that you can reproduce every day and in which you're not impacted by all sorts of other stressors. If you measure first thing in the morning, before breakfast, before exercise, before coffee, and those sort of things, and that is a state that is always a resting state and where you can measure this stress response accurately. And the same is during the night. During sleep, you measure the entire night. The average of the night will be very similar to the morning as a state of rest in which you can capture physiological data. This is not the same during the day, again, because there are all sorts of transitory stressors, even just your mind wandering or any sort of movement or activity. And that is not really what we are interested in when we want to see what's our state and how we are responding to the larger stressors that have a long-lasting impact and not just an impact of a few minutes. Now, when we take that measurement, then we also need to interpret it in a way, right? And that links back to what you were saying about the absolute values and the trends. So physiology is very individual, and heart rate variability has also strong genetic component. So typically when we take a measurement, and that's our first measurement, even if we did it at the right time in the morning or at night, that data point does not really tell us anything because there is, let's say, no clear normative values, right? So similarly to some other signals, we might know that certain values might be slightly better or slightly worse than others. But even if we look at resting heart rate, for example, we know that what is considered a normal value is an enormous range, right? For an athlete, it could be in the 30s, but still up to 70, maybe 80 is still considered normal in medical practice. So there is a very large range. If your heart rate is 65 and you are an athlete with a heart rate that normally is 35, then you're certainly sick because something is really wrong. But if another person has an heart rate of 65, it might be perfectly normal for them. For HIV, it's similar. The absolute value does not tell us that much. And that's why we should take these measurements at the right time, but also every day, longitudinally over time, so that we start building what we call a baseline, so simply a trend over time of what's our average this week and next week and so on. And then we can see changes in response to stressors. For example, again, if we get sick, our HRV most likely will start to get suppressed, and then things like that. Then also the recovery phase can also be captured that way so that we have an objective marker of the body's recovery from the stressor, which can also be equally useful to decide the course of action.
Mm-hmm. Very good. So the different tools we use to measure HRV, can we just go through those briefly as far as what's available to people from a standpoint of commercially and then clinically?
Yeah, for sure. So, well, I run a small business which is called HRV for Training. So we make an app which you can use to measure HRV using the phone camera. So in this case, does not require any sensor. The technology is similar to what you have in watches and other sensors that have dedicated sensors basically to flash a light on your skin, and then another sensor that measures the change in light absorption when the blood is flowing. We do the same by using the flash and the camera of the phone, since the flash can act as a light, and then you measure the change in blood volume. That way you can reconstruct heart activity because, of course, blood is flowing when the heart is beating. So this is a different technology that we have developed and now is present in other products as well that allows you to measure HRV with basically minimal cost and no sensors required. There are some wearable sensors that can also measure HRV accurately. For example, the Oura Ring, for which I'm also an advisor for disclosure, but develops a ring that is able to measure HRV accurately during the night. Similarly, there is the Whoop band, also marketed to athletes, but is a good device just in general to measure HRV during the night. The Apple Watch can be used for spot checks using the Breathe app that is present in the watch, but the data that it collects automatically is not very good. So I would not rely on the data collected automatically because it's sporadic measurements here and there. It's not a continuous measurement throughout the entire night, but you can use it for an accurate measurement in the morning. So that is another way to do it. Of course, there are chest straps, typically more used in exercise, but Polar chest straps or Garmin chest straps are very accurate, and another way that you can measure paired to an app like HRV for Training or others, you can get the data through the strap that uses ECG directly, so not PPG, not the optical technology, but both methods can track very well changes over time as you experience different stressors. So these, I would say, are a bit of the options we have for commercially available and easy to use, I would say, at this point, tools. I think this is where a lot has changed maybe in the past 10 years. HRV is nothing new, right? The research we talk about is maybe 50, 60 years old. But what has changed a lot is our ability to measure, that in turn also led to a lot more and better research because we don't measure HRV in the lab and then 3 months later again in the lab, but we are actually looking at how things are changing every day at home. And I think that's very powerful.
Yeah, absolutely. And is there any new research about using HRV to predict other aspects of health? So for example, I think most people think of HRV as more of like a readiness metric of training, performance, optimizing your day-to-day conditioning, those types of things. I have a special interest in using it to help people gauge when they might be experiencing like a flare-up of a chronic illness, for autoimmune diseases, those types of things. And I was just wondering your thoughts on that, as if we're going to be seeing more and more of that in the research.
Yeah, for sure. I think it started with athletes mostly because there was maybe, um, well, let's say that using the technology also required some work, like you had to actively take these measurements and be motivated to do that. And maybe that's a type of person that is initially more motivated to try these technologies because they have their performance to improve, these kind of things. But what we measure has nothing to do with exercise in particular, right? That is the interesting aspect. And actually, most people that start tracking it, they will soon realize that training is not what has the biggest impact on their HRV or resting physiology, even athletes, because they will be used to training in a way that their body does not show large changes in response to training because that's a stimulus they can assimilate and respond to very well. But then maybe they're traveling or they change diet or they're stressed because of a new contract or some other issue at home and those sort of things. Or they get sick. And that's when the data becomes useful to manage what is outside of what you know and do very well, which is your training or something else. And in the context of chronic disease or even just acute regular sickness that we might encounter, these signals reflect very well the state simply because, again, it's just the state of your body in response to what is happening. So in the acute state of sickness, you will typically have a very high heart rate and very low HRV, and these kind of signals track very well with the symptoms, to the point that sometimes you might see also the change maybe slightly before you have actually experienced other symptoms. So this does not mean that there is, in my view at least, I do not think that the signal is predicting really something. I think simply that something is already wrong and is simply reflected there in a way that maybe it's reflected earlier than through other symptoms and things like that. So it can be helpful that way, but not necessarily happening before. Often it's at the same time, but still it just gives you an objective way to see that maybe that's a day where you need to be more careful or act a bit differently.
Yeah, I think that's really helpful, especially since stressors, predicate flares often. And, if a lot of us, including myself, I think, we're wired to sort of push through and overcome, fatigue, or overcome our resistance, or overcome things to accomplish our goals or accomplish our daily tasks. And, it's kind of, to me, for those of us who do that, another objective way to say, hey, you're reaching your limits, and you need to adjust the gauges or implement some lifestyle choices that will bring more homeostasis to your body.
Exactly. It's eventually an objective way that can allow us to maintain that balance a bit better.
And a lot of people I talk to just don't have, I think that the term is called interoception, where you check in with your body and you do basically a body scan to kind of give yourself some subjective feedback as to your balance. And I hear over and over how many people just feel like they lack that skill, or they lack that ability.
Yeah, I think that's really a great point because sometimes one of the critics, right, to using this kind of technology is that maybe we become over reliant on the technology and less on our feel and things like that. And personally, I think that that is not the purpose of the technology. On the contrary, it is there to enhance our ability to, improve our interoception and our ability to also perceive stressors and changes that are more or less important. Yeah. So I think that by using the technology, we don't use it just to, not worry about actually thinking about how we are feeling, but we use it to fine tune that in a way that we can become better at it.
Exactly. Yeah. It's the awareness and connecting and learning your body and learning the feedback. And I imagine over time, people sort of can predict what their HRV is based on how they feel when they wake up in the morning.
Yes, exactly. For sure, we get better at that too.
So the variables that pair well with HRV, is there anything that you like to, I would say, group with it as like a dashboard of performance or health that would complement it well?
I think it's always important to look at it together with other signals, like not to, this is an important marker of stress, but it's important to also have a lot of context around it, because when we have only HRV, if we look at HRV for one person, typically we cannot say anything about what is happening because we don't have the right context. So it's important to look at maybe other physiological signals as well, even just resting heart rate. If we look at HRV and resting heart rate, in many cases, they will go in a similar direction, right? So opposite but similar, meaning that there is a stressor, heart rate is a bit higher, and HRV is more suppressed. But then there can be cases where maybe these changes are a bit different. So maybe just one of the two has a marked change. And that's something that is also informative. For example, in a study we did recently, we looked at many different stressors and we saw that most stressors would cause very small changes in heart rate. For example, training or the menstrual cycle would have much smaller changes in heart rate than in HRV. But then when we look at strong stressors like sickness or excessive alcohol intake, then you would have a very large change both in heart rate and in HRV. So that tells you that on a day-to-day basis, if your heart rate is particularly elevated, that tends to be a red flag. While if your HRV is suppressed and your heart rate is normal, then it might be a more subtle stressor that can be still important, but maybe it's not linked to sickness. So again, different ways then in which you would interpret the data. And together always with, I think, subjective data as well is very useful context. So how are you feeling in terms of fatigue, energy level, all sort of things that can help contextualize the data, as well as, again, the environmental variables. So things like where are you and the temperature and all these kind of things that have an impact on your physiology. So I would say combining these kind of things for athletes, of course, there is also training, but outside of exercise science and training, I would say the objective and the subjective data together, tracking those can be helpful to try to figure out better way to maintain things in balance.
So let's talk a little bit about breath and breathing practices, and I guess alongside that, meditative practices. Can these over time change someone's baseline HRV?
I think there's a really interesting question and topic in general, as we always think about stressors as negative stressors, right? Until now, I think we always talked about these aspects that will suppress your HRV, and it's normal to always think in those terms. I always think in those terms, but then you can also try to actually have some sort of other, let's say, positive stressors that go in the other direction. So deep breathing, especially breathing and what is called the resonant frequency, which means simply the frequency at which your HRV is maximized, by definition, will increase your HRV, at least as you do the exercise. So this is typically, to keep things simple, for most people is about 6 breathing cycles per minute. So that means that you breathe in, for example, for 5 seconds, and then breathe out for 5 seconds, and then basically you have 10 seconds for a breathing cycle, which means 6 in a minute. And that is sort of slow, deep breathing that increases your HRV acutely as you do it. So this is a form of training, you could see even, you could see it that way in terms of training of the parasympathetic system. So we stimulate it that way, especially maybe the exhale, you can keep it also a bit more longer than the inhale, because the parasympathetic system is more active during the exhale. So it will have a larger impact on your heart rate variability that way, and you can exercise that way. So this has been shown to have several benefits in terms of, say, sleep quality, anxiety or depression, so managing this kind of conditions. In terms of changing your baseline, I think there it's up for debate still. So while it is clear that there is an increase in HRV acutely as you practice, normally protocols would require to do this kind of breathing for 10, 20 minutes per session, once or twice per day. So obviously you can start with less just to get in the routine and then try to build up towards a higher dose, let's say. And then the changes in baseline HRV. So does your HRV then, after a few weeks or months of doing this, increase? I think it is not that clear. Most likely there are some people that respond that way and have a larger change. Other people that maybe do not have that kind of change, but it does not mean that they do not experience other benefits. For example, when I do this kind of practice, my baseline HRV does not change over time. So for me, it does not have that effect, but I do feel better, right? I do feel more relaxed and less anxiety. So I think there are benefits that in general we know from mindfulness and meditation, even though you do not necessarily have a change in your baseline physiology.
Yeah, great. Thank you for walking us through that. That's helpful. And, I downloaded your HRV4 training app, and I've been using it, and I really like it.
Glad to hear.
I like the practicality of it. Just I have my phone on airplane mode, overnight, and then just grabbing it first thing in the morning. The consistency of it and the ease of use. So I just want to thank you, and just let you know that I'm really happy to be using it. And maybe it would be great just to talk a little bit about my early experiences kind of as a case study.
For sure.
Yeah, so talking about the first 4 data points, it went from 8.1 day 1 to 8.2, back down to 8.1 day 3, and then it was around 7.1 day 4. And so that, to me, I guess from a bird's eye view, it's like, okay, it's pretty consistent, but that actually seems like it's a consistent drop that 4th day.
Yeah, it does sound like it. I think that actually this brings up some important points about also how to quantify these changes, what is a meaningful change, and all of that. So as you keep using the app, you will see that the app will report what we call a normal range. I think this is also something that is not present in many tools and not something we are not really used to, because we often have this simplified view of higher is better or lower is better for this kind of parameter, everything that we measure, while obviously there is an optimal range. I think we are familiar with the optimal range in other contexts. For example, when we do, maybe blood tests, we know that for most parameters, we have this range where we should be within. And also with blood pressure, when we measure it, we have normative ranges at the population level. Now, for HRV, we said there are no such absolute values, right, that we can use as normative values for everyone. But that does not mean that it's as simple as higher is better. There is still a normal range, but that is specific to you. So what the app does over time is that it learns what's your normal range. For example, now you have 4 data points. So it will start exactly with 4, I think, already to build your normal range. But then over time, it will use always the last 2 months of data to determine what is normal for you. I think that is important because there is also seasonality in physiology. So it is normal that in winter, our HRV is a bit more suppressed with respect to summer. So we cannot just rely on the data that was collected maybe 4 months ago to determine what is normal for you. We always need to update that with new measurements, and that's what the tool does automatically. And then it will be able to detect when a data point is meaningfully or significantly outside of what is considered your normal range. So for example, your score today seems quite a bit suppressed, possibly outside of your normal range. So that means there might be some stressor there that caused this suppression.
Yeah, I mean, I did change one variable just to kind of see if there was a change. And so the variable that I changed was I drank a afternoon coffee, like a strong one, not just like a little, baby coffee. It was a strong one. And I usually don't do that, but I was just curious the impact of coffee and caffeine on this parameter. So that was just the main change between those 3 other nights and last night.
Yeah, that makes sense. I mean, coffee is a stimulant, so it could also cause that type of response. Some people have a slower or faster metabolism, so it could be that for some it stays longer.
Yeah, I imagine it didn't help my sleep probably.
Yeah, exactly.
But we'll see. But yeah, it's a very good tool, and also one of the things I like about it is, just sort of learning how to pull back on the throttle based on the feedback your body's giving it, and then on various days where you're more in performance mode, to challenge yourself, and dress yourself in a healthy way. I think that's stress is not always a bad thing, right?
Exactly. It's really the point is not to avoid stress, but is to see how you respond to stress. And when your HRV is stable, like it was, for example, for you for those days, it does not mean that you're not experiencing stress. It simply means that you're responding positively to that stressor. So that is actually good to see. Stability in the data means good response. And then if there is a stressor that you're not responding well to, then that would show as a suppression. And that's maybe something where you can work on, and with things like we discussed earlier, also breathing exercises or just taking it easy in general.
Mm-hmm. I see often, like, I get some of your emails and you're involved with a lot of different things, in also getting other people involved with HRV mentoring or coaching. Can you just give us a sample of what you're up to in some of the projects you're working on?
Yeah, for sure. I think we tried to look at a bit different projects in different contexts. For example, we talked a lot about the morning measurements and tried to see how we respond to different stressors and things like that. So that is, to me, always the most important aspect, because we quantify a response, and then basically you allow the individual to be more aware of what kind of changes are happening, and then to take control in that way. So it's not as much as about discovering anything about the relationship between these parameters, because I think it is so individual that now it is more about providing an easy to use tool and an interpretation of the data with respect to an individual's normal range and things like that, that allows the individual to do themselves the math, so to speak, so to understand what is it that is causing changes for me, positive and negative, what kind of stressors do I experience, and these kind of things. Then we also look at in more research settings at maybe specific stressors and measurements at other times. So we could look at exercise and measurements before and after exercise done at different intensities or in different modalities. See if there are certain patterns that show, for example, better physiological response. So if we do low intensity exercise, and we talk a lot about it in terms of health benefits and what is sometimes called zone 2, but simply just easy aerobic exercise, we see that the effect of the exercise session on parasympathetic activity is actually basically the opposite of what you would expect. So right after exercise, the data is stable or even better than before, despite the fact that there was the exercise stressor. But you need to be able to be sure that you were doing the exercise at that low intensity, which for people that are not athletes typically means extremely low. So it could be walking instead of cycling or running, because that would already bring you outside of that low intensity zone if your aerobic fitness is not good enough. And that is also obviously something you can work on and build on over time. And other aspects are linked to the breathing part that we were discussing before, where I think there is more uncertainty on the effect. So we are curious to see also, okay, maybe doing these exercises daily does not change your baseline in terms of increasing it, but does it keep it, for example, more stable? Maybe if we do these exercises, our baseline will have less ups and downs, and we will be keeping that more stable, which is also associated typically to better responses. So we are looking at measuring that a bit more systematically in different studies so that we can see if that can be quantified, and and then we can show the benefit of the exercise that way, or if biofeedback and deep breathing exercise does not bring the benefit, that would also be important to know. So I would say different aspects that are being analyzed.
Excellent. How do people follow your work and get more involved if they want to dive deeper into this information?
I would say mostly on Twitter these days. My handle is at Altini_Marco, so last name _ first name. Otherwise, the HRV for Training website also, which I do blog a fair amount about all the things we do. I would say those are the main resources.
Excellent. And we'll put links to those in our show notes, and also your great article that you posted on Medium. I think it was like a 4-part article.
Yes, thank you.
It's amazing. Any closing thoughts you want to share with us? I know it's late there or getting later there in Amsterdam, so I don't want to keep you too much longer.
It's good. Well, nothing in particular. I think this was a really good chat on many aspects. So I'm really grateful to be here.
Thank you so much for tuning into this week's episode of the One Thing Podcast. Please share these episodes with your friends, loved ones, colleagues, patients, healthcare providers, anyone who you feel might benefit from hearing these informative interviews. We tend to learn best from people sharing things with us. That's often the first time it's introduced. So don't hesitate if the content of these episodes reminded you of someone that might benefit from it. Forward the episode to them, and I'm sure they'll either appreciate it or be appreciative that you've thought of them. So once again, we'll look forward to seeing you next episode on the One Thing Podcast. And again, much appreciation for you being here with me.